carbon dioxide, methane, nitrous oxide, and like that they've listed out everything that comes as an output. Because even microscopic level of information is being quantified. Because they need to be disposed, they need to have some form of plan. But when you look at the figure of it, you will see the larger figures are the obvious things that you know of. For example, the carbon dioxide emission to make 1 kilogram of steel sleeper is 2,562 grams. So for 1 kilogram of steel sleeper, they make 2.56 kilograms of CO2 as emission. Okay? None of the others are in anywhere near that scale. They're all in 10 to the power of minus 6. Coming back to methane, they emit 0.23 grams of methane. So the methane production is low for sleeper. Nitrous oxide is even lesser, 0.07. Okay? So if you use these outputs to make an equivalent carbon output, carbon dioxide output is now called as equivalent carbon dioxide output, because everything can be brought under the carbon dioxide to then give a total figure. Okay? So the way it works is, I will add the carbon dioxide output, I will then add the methane and the nitrous oxide, because in this exercise I'm looking at global warming potential, so I know these are the three major chemicals I need to look at. And I'll multiply the methane by number 25, and then multiply the nitrous oxide by 298. That's because 1 gram of nitrous oxide is 298 times more lethal than CO2. 1 gram of methane is 25 times more lethal than CO2. So if you have a production which emits more methane, it has much more, 25 times more impact than something which might be spewing out CO2. Okay? So not many things that you think impactful are really that impactful. There's a lot of other things that are a lot more impactful. Okay? Leather production put out a lot of chromium. Am I right? Are you familiar with leather production of leather and cleaning of leather products? Chromium is extremely impactful. So it might turn out that the leather production and the manufacturing and the cleaning exercise have more human health and global warming impact than concrete production, which is not true because the volume is just unbelievably uncomparable. Concrete is just everywhere. Okay. So these databases, these values exist in the database, and that's why I'm saying this is a business where you have to use a software. You're buying these information. This was given to us by Tata Steel, or then Chorus Steel, for their production based on 2005 figures. So if I look at it now, because all the steel plants would have made better systems, these values will be completely different. And this is why I said you need to have a person who's trained to do it and is up to date in this business. So software allows you to put all the figures and factors for each of them. Software knows, most of the new softwares know these values. If you don't have it, they will automatically take from a database. And together they compute everything, and in the end they will give you the impact in the categories that you're looking for. So this is the what we looked at, that precast yard wanted us to tell impact on two different factories. One factory had an older machine systems. The latest factory had very new efficient systems. And you can probably tell which one is the later factory. The yellow is clearly the newer factory. But they just wanted us to do that exercise so they can get the software and training, and then they use it for their products. Technically what they wanted was to put a carbon footprint on their products. And they have to, the way the carbon footprint looks like a footprint? Quite often products have these, and then they will say CO2E, equivalent CO2. That's how they derived. So the results says carcinogens have a factor of that. The factory A produces this much less carcinogens than factory B. Okay, And it's only factored to 100, so it doesn't mean that we have this many output. It's a comparator scale. Like that, you can say respiratory organics, blah blah blah, climate change, acidification, fossil fuels. So you can decide what output you want. Quite often we only report climate change. Okay, that's because you're looking at climate change as an output. Sometimes we need human health assessment, so we might do this one: carcinogen, respiratory organics, inorganics, ecotoxicity. That's it. That makes the human health impact. Okay, so that's how this is computed. Human health is computed by all of that together. Resources are computed by how much more wastage does each of these products have, how much more diesel does these products use, and that's compute the resources. So basically your waste and the diesel usage tells the story. And when we run this analysis, we know by looking at it that the diesel usage in all of them plays a bigger part. They're more impactful than the material that we're taking out, which is okay because that's concrete production. Okay, you can then give it a relative scale. Every software will tell you what approved scale systems are to scale things down, because then you have to be comparable to a global scale, and that's what it does. And you can also represent everything in one graph. This is human health, that's ecosystem, that's resources. It's a concrete production, so you would expect the impact on resources to be more than human health, would you? Which is true. That's what you're seeing, more red than blue. Okay, it's not important we go into that because I'm going to lose time otherwise. It's a bit rushed through that one, but taking that through in details would need more time, and also that doesn't work unless you do practice yourself. So my suggestion is to download one of the softwares, either Gabi or SEMA Pro. They have inbuilt examples in it. So I think SEMA Pro has a timber shed. That the timber shed has a size and space and all of it. Number of nails is calculated, the number of planks are calculated. And they take you through all that in very detailed fashion. Use that example if you're using for teaching. Yeah, sure. Sure. Okay, we'll restart. You have two choices at this moment, okay? I have given you the introduction to most of the topics, except I just want to say something about the end-of-life management of structures. These are all sort of peripheral information. You're aware of it, of all the topics, so I'm trying to bring that under one umbrella. The other option is that tomorrow I'm going to take you through two examples in detail of structures that I was involved in retrofitting and rehabilitation as well. And if time permits, I can also go through another structure which we haven't done much work, but we're about to start the work. All of that will show you the approach that we're taking. So when I said choice, if I can go fast through here, then I can tell you how we use sensors to assess the performance of repair. I might be able to do it today, but given that time is 43, I probably will push it for tomorrow. So it's not important that we go through the slides in detail. You have access to the slide in the notes, so that's not the intention here. But the intention is to ask a few simple questions to yourself, and also to accumulate the knowledge that we have on end-of-life management. What does it mean by end-of-life management? What do you think? Quite often when I use the word, people will say, you're talking about the funeral cost of it. Essentially it is. I'm looking at how do I put the site the way I found it when I went to the site. If I can rehabilitate everything the way I found it, then that's what end-of-life management refers to. In the UK, if you go and bid the tender to build a classroom for a school, the requirement is that you put the site back in the condition that you received. It's a 15-year program that you have to build the classroom, you have to let the classroom be there, and you have to provide the service for the classroom to be in the right shape. 15 years later, when you take everything apart, site should be the exact same way as you found it now. That is a requirement. How would you do it? So, school needs extension now. They're intaking new students in the coming year. You have 4 months lead on time. The school authority, which is council, is saying this is the area that you can expand into. It's a greenfield site, so it's a grassy area. Put the school room to facilitate 100 students, 2 classrooms or 3 classrooms. 15 years later, when we get a new school built somewhere else, I want everything back to be in the greenfield site. That is what the briefing will look like. My question is, what approach would you take? Would you go for a solid construction, or would you go for a temporary construction? 15 years is a short time, yeah? And it's a school building, so it's not loaded, depending on how many floors. Like if it's a single floor, then it's much more easier. All you need is a container, essentially. Good container, clearly. And they also will specify what way the floor should be, what should be the walls, the echo, the noise effects of the wall. Everything is specified. That means up to the whiteboard, from the lighting and everything needs to be delivered to site and taken away from the site at the end. The way they do it, fibers. You know the fiber boards? So they use fiber boards, they create composites, they put windows in everything. Everything is done factory setting. And they probably have it in 2 halves, transported in flat pack lorries, brought to site, dropped on, possibly on temporary props, which could be just a masonry construction, or they will have some form of foundation rafts within the structure that it can just sit on its own. Only from come from the ground. So that's the only permanent remark of the structure ever being there, which at the end of the project they can pull it and then they go. And that's what they do. That's what they do at the moment. And they bring it back in 2 sections. Bring it on site, they just join the 2 sections, run the roof on top of it, which very likely will be some sort of felt membrane. 4 weeks, they're in, they're gone, and do the job. Okay. Remember, that company, whoever did it, or that contractor who did it, is responsible for building everything. They're responsible for maintaining it. They're also responsible for taking it away. Okay. 1 ton of inert waste disposal costs 44 pounds. Inert waste is sand is inert waste, clay is an inert waste. All of those inert waste things cost 44 pounds per ton. We expect by 2020 to go to 75 pounds per ton. You take it to landfill, you pay 75 pounds. In 2020, you'll pay 75 pounds a ton. So disposal is not an option. Yeah, you bring it to site and then your lorry comes empty. They will take it at a cost of 75 and they will charge you. The disposal companies can make their money. And they get it off you and then they separate it. Sometimes it's costly business, sometimes it's not. But that's the cost that they will get. Okay? So you will have to be clever in your design because you will have to take everything apart. As much reusing as possible should be done, should be thought of. You will also need to look at how many lives do I get out of that room. Can I make it a school room for 15 years? Can I bring it and assemble it as my factory extension yard to serve another 50 years or 15 years. So you have to think of how many cycles of it. A contractor is in the business of putting school buildings. He or she is not going to say, I'm going to use it as my office. Because they already have an office. They are in the business. They're doing hundreds of these. So they'll bring it back from site. After. So if their company is established 20 years ago, they're already doing it. They take everything apart. Everything is detachable. And they even know how to detach it. You just need one person with the automatic screwdriver to take everything apart. This material is for school kids, so it needs to be really tough because school kids are highly energy particles. So, but they will be able to take everything apart and then recycle it, or they find a different use to it. And that logical thinking is the end-of-life management of it. So, the building materials that we use, what are the building materials we use on the wall? What building materials do we use on a wall construction? So the brick, the mortar, and do we use only brick and mortar? Then I shouldn't be able to see the brick. Some form of fillers, painting. Anything else? What is it? Tiles, yes. Electrical conduits. Water pipes.